Back. So as promised, we are going to do this problem again, just with a different way. So we are, in the last video, we squared two of the terms to make it fifth degree. By the way, there's no reason that you had to square x minus 3 and x minus 1. You could have very easily have squared x minus 1 and x plus 6. But your a value would be different. Just keep that in mind. So in this video, instead of going that way, oops, I want to do something else, and instead I'm going to cube one of them. So other than that, we have the same setup for this problem, same restrictions, same x-intercepts. So I'm going to have a times x minus 3 squared, and let's just leave that one as is. X minus 1, we'll leave that one as is, and then we're going to cube x minus 6. Okay, so again, this is a fifth degree now because I have 1, 2, 3, 4, 5 linear factors. Great. So now I'm going to do this exact same thing that I've been doing. P of 0 is equal to 300, meaning I have a times negative 3 times negative 1 times, okay, 6 cubed is 6 times 36. Right, so that's 2 6's there, and then, sorry, 1 6 right there and 2 more. I know it's 216, but, or sorry, do I know that? Yeah, it is 216. But it's going to make it easier for me to just divide this as is. Okay, so what's going to happen here? I will divide both sides by 6 to get that. So I'll get 50 equals a times 3 times 36. I guess I can do a little bit more dividing here. I could divide everything by 2. By 2. This will be 18. This is going to be 25. I think this ends up being 54, and I don't think I can do any more after that. So it looks like a is just going to be 25 over 54. Alrighty. So that's what that's going to be. P of x is equal to 25 over 54. Oops. Times x minus 3, x minus 1, x plus 6 cubed. I believe this should be x plus 6, right? Alrighty. So now that we have that, we just need to graph it. Alrighty. So alrighty, folks. So we are going to graph this guy. Sorry, we had some technical difficulties. But here's my setup. I have my x-intercepts and my y-intercept all set up, and I'm going to draw it going from the y-intercept and going off to the right first. So just like before, we saw where if you have a multiplicity of just one, similar to this guy over here, the x plus 6 term, excuse me, it just goes straight through from one side of the x-axis to the other. So, oops, sorry. So that's what's going to happen at x equals 1 and x equals 3. So that's going to go down like this, go straight through, turn around at some point, and then come back up like so. Okay, now what happens at the last sun, at the x equals negative 6 root, excuse me. So I want to take a look at what this function will look like normally. So if we just graph the function, y equals x plus 6 cubed, this is the graph you're going to see. You're going to see something like this. So it's going to happen at negative 6, and it's going to have this kind of funky S-like shape. That's just the way it looks. You confirm with Desmos if you don't believe me, but that's what it's going to look like. And so when we graph our blue function, p of x, at x equals negative 6, that's what it's going to look like. So the way we're going to draw this is just like so. It'll come down. Again, my scale is super awkward, but it's going to look something like that. And then like that. It's not just going to go straight through like it did over here. Okay. The reason I want to point this out is because this graph does not have 5 different directions like the previous one did. So you can see over here, oops, it has 1, 2, 3, 4, 5. It goes up, down, up, down, up. This one doesn't do that, right? So it starts off going, again, from left to right. It goes up. And then when it hits that x-intercept, usually we think it's going to change direction. This one doesn't. It goes up, and then it still goes up. And then it goes down, and then it goes up again. So again, remember, just because your polynomial is fifth degree does not mean it's going to have 5 different directions. At most, it could have 5 different, but it won't always have 5. So again, if we're sketching it, how do I know it has the right shape? Just make sure you have the right x-intercepts and whatever that final not x-intercept point is. In this case, it was the y-intercept. Make sure all those points are correct. And then just make sure that your graph looks the way it's supposed to look at the x-intercepts. So again, with multiplicity 1, it'll just go straight through like it did here. At an even multiplicity, x squared or even x to the 4th, they'll pretty much all look very, very similar. They have this bouncing off action, right? Again, that came from here. Or if it's x cubed or 5th or an odd power that's not 1, it'll look like this. Oops, let's draw that just like that. Alrighty. And those are really the things you're looking for when you're sketching polynomial functions. Alrighty. Thanks for watching. Hopefully this helped. I'll see you in the next one, folks.